Alright, so picking up where we left off, we were doing the pizza delivery example, and we had found a p-value of 0.0057. And that, in the case of the criminal trial, is the evidence. Well, how do we know if that is sufficient evidence to reject H-naught? Well, here we have a level of significance, and we're going to compare it to that. The researcher decides on a cutoff point before running the test. They call it alpha, or the level of significance. There are three common values of alpha. There's 0.1, 0.05, and 0.01. And 0.05 is by far the most common, and that rare event rule is basically the same as this. So 0.05 is considered to be a small probability, and if there's ever a time when they don't give you a level of significance or a value of alpha, you can just assume 0.05. Probabilities that are unlikely are always going to be below that level of significance. So the rejection rule is reject H-naught if p-value is less than alpha, the value of alpha given in the problem, or 0.05 if it's not given. Regardless of whether the alternative hypothesis is lower-tailed, upper-tailed, or two-tailed, it's always reject H-naught if p-value is less than alpha. So for now and for the rest of the course and forevermore, it's reject H-naught if p-value is less than alpha. And this is so important that I actually had a stamp made, and they wouldn't let me do a subscript on the H-naught, but reject H-naught if p-value is less than alpha. I cannot emphasize that enough. Always reject H-naught if p-value is less than alpha. So it seems like no matter how much I try to drill that in, people still get it wrong. So write it on your note card if you're keeping note cards. Reject H-naught if p-value is less than alpha. So back to our pizza delivery example. We suppose the researcher wants to use alpha of 0.05. The rejection rule is then going to be reject H-naught if p-value is less than 0.05. Our p-value is 0.0057, which is obviously less than 0.05. So our conclusion is reject H-naught. There is sufficient evidence to conclude that the mean of all delivery times, the population mean, is less than 30. This supports the restaurant's claim. Okay? So that's the conclusion. If by chance, if our p-value had come up differently, if our p-value had been 0.13 or something that would bigger than 0.05, our conclusion would have been fail to reject H-naught. There is not sufficient evidence to conclude that the mean of all delivery times is less than 30. Okay, so that's our first example. We'll work through another couple of examples in just a minute. For every hypothesis test, there are two possible conclusions. Reject H-naught or fail to reject H-naught. If we reject H-naught, that means that there is sufficient evidence to conclude that whatever the alternative hypothesis says. So, reject H-naught, there is sufficient evidence to conclude the alternative hypothesis. Or else, you could fail to reject H-naught. There is insufficient evidence to conclude that whatever the alternative hypothesis says. Okay? These are the only two conclusions for a hypothesis test. Reject H-naught, there is sufficient evidence of the alternative, or fail to reject H-naught, there is not sufficient evidence of the alternative. So let's do a second example. So suppose that the mean weight of all newborn babies in the U.S. is 7.4 pounds with a standard deviation of 2.3 pounds, and that would be the population. A study was conducted of babies born to women who were diagnosed with gestational diabetes, which tends to increase the weight of the babies. So of the 35 babies in the study, the average birth weight was 8.1 pounds, and they want us to use alpha equals 0.01 to determine whether the average birth weight of these babies, of all babies whose mothers suffer from gestational diabetes, is higher than the national average. So the first thing we're going to do is we're going to set up our hypotheses. So we want to see if the population mean is greater than the population mean of the babies from gestational diabetes pregnancies. So if these babies have a population mean greater than the overall population, 7.4, if it's not, then we're going to assume the null hypothesis of equals 7.4. If we plug in the values to the z-test statistic, we have a sample mean of 8.1 compared to the population mean, the hypothesized value of 7.4, over sigma over the square root of n. We said sigma was 2.3, n was 35. If we do that calculation, we get 1.80. The alternative hypothesis here is greater than. So the p-value is going to be probability z is greater than 1.8. So you can look up 1.8 on the z table. We're going above it, so it's 1 minus the 0.9641 that we would get. We get 0.0359. That's the p-value. Reject H0 if p-value is less than 0.01, and that means that we would fail to reject H0. There is not sufficient evidence to conclude that the average birth weight born to mothers who had gestational diabetes is higher than the average birth weight of other babies. Alright, so on this one, again, our p-value was not less than alpha, so we failed to reject H0 and said that there is insufficient evidence to conclude what the alternative hypothesis says, which is that mu is greater than 7.4. Here's another example. The chocolate chip cookie maker wants to have an average of 10 chocolate chips in each cookie. If the average differs from 10, the maker will recalibrate the machine. A sample of 40 cookies has a mean of 9.1 chips per cookie, and we are assuming the population standard deviation is 2.0. Using alpha equals 0.01, should the machine be recalibrated? And again, because we have the sample, or because we have the population standard deviation, that means that we're using z and not t. So this one, because there's not a clear indication of whether it's less than or greater than, the alternative hypothesis is going to be not equal. So for this example, we have H0, which is mu equals 10, versus HA, mu not equal 10, because remember they want to know if it differs from 10. If we plug all those values into the test statistic, 9.1 the sample mean, 10 the hypothesized value, over 2 the standard deviation over the square root of 40, we get negative 2.85. For a two-tailed hypothesis test, we're going to have 2 times the tail probability. The tail probability is probability z less than negative 2.85. And when we do that, we get 0.0044. Because alpha in this problem is 0.01, we're going to reject H0 if p-value is less than 0.01, which means because this p-value is less than alpha, we reject H0 and say that there is sufficient evidence to conclude that the mean number of chocolate chip cookies differs from 10. So we would recalibrate the machine. So there are a couple ways we can do hypothesis testing. The first is the p-value method, in which case we're calculating the p-value and we'll reject H0 if the p-value is less than alpha. We're going to use this method because that's the method that's really used every time you read a journal or, in the real world, this is how it's really done. The other method, which you'll see in textbooks, is the traditional method in which you use the test statistic and not the p-value. But the p-value is much easier, I think. We're not going to use that. Let's talk briefly about some errors. So when you conduct a hypothesis test, it's possible to make an incorrect conclusion. And there are two ways this can happen. You can wrongly reject H0. And if you look at the criminal justice analogy, that's going to be convicting an innocent person. That's a type 1 error. So they call that a type 1 error if you reject H0 when you shouldn't. The other type of error is if you fail to reject H0, and that's an error. So in the criminal justice analogy, this would be acquitting a guilty person, and we call that a type 2 error if you fail to reject H0 in error. In criminal cases, just like in hypothesis testing, we consider a type 1 error to be worse than a type 2 error. And so in both criminal cases and in hypothesis testing, those are designed to minimize the probability of a type 1 error. There is a way you can analyze type 2 errors, but that's an advanced topic that we won't get to. All right, I think doing the z-test calculations by hand will help you understand how it works. So I want you to be able to do the z-test by hand as well as using StatCrunch. The z-test, I'm not going to ask you to do any other hypothesis tests by hand except for the z-test. You can see in StatCrunch how to carry out a z-test. As you're doing these, always keep in mind, and don't lose sight of the fact that we're using what's in the sample to make a guess about the population. So we know what the sample mean is, but we want to know, is that enough evidence to conclude something about the population mean? All right? So good luck.